Hello and welcome to Maximum Code. Hope you're having a wonderful holiday season. In this tutorial, we'll unlock the full potential of IBM Granite LLM with function calling. I'll show you how to create powerful AI applications that can perform real-world tasks through custom functions. Whether you're a developer looking to enhance your AI toolkit or just getting started with large language models, this guide will show you exactly how to implement function calling with IBM Granite. Here's what you learn: setting up your development environment from scratch, implementing IBM Granite LLM with function calling, creating a server that uses OpenAI compatible standards, building and testing your first AI function using .NET. This tutorial is perfect for both beginners and experienced developers. I'll walk you through every line of code, explain each step along the way. Don't forget to like and subscribe, and hit that notification bell to stay updated for more AI development tutorials. In this tutorial, we'll walk through creating a Python service that mimics OpenAI's standard chat completion with function calling. We'll kick things off by installing the necessary libraries and setting up the code in VS Code. You'll be able to launch and debug it to better understand how everything fits together. At this stage, we won't dive into the code in detail, just a high-level overview to get you familiar with the process. Once we have our Python service up and running, we'll interact with it using C# code through the OpenAI NuGet package. The goal here is to create a scenario where we ask a question, pass it a function, and our servers decide when to call that function based on the user's query. To achieve this, we'll send the function description as a tool to our Python service, allowing the service to reference it when necessary. The service will then check if any tools are available. If tools are detected, we'll extract and generate a system prompt, combine with the user's query, and send it to the LLM for inference. The LLM will return a response indicating if a function call is required, complete with valid parameters. We'll relay this information back to our C# code, which will execute the function and send the results back to the LLM. This final interaction allows the LLM to generate a human-readable response based on the function's output. In the end, we'll arrive at the result, a clear and accurate answer to the user's query, seamlessly generated by our Python service and C# integration. This installation is very similar to our previous video. As a matter of fact, we will be using the same Anaconda environment. Make sure that you have Python 3.11 installed. Next, head over to NVIDIA developer site and install both CUDA and cuDNN drivers. After that, head over to pytorch.org and install PyTorch based on the CUDA driver you've installed. If you don't see your driver version, then use the latest one. It should be compatible. This process might take some time as it may compile the libraries for your system, so please be patient. Our installation took over 30 minutes, and hence we're using the same environment as the previous video tutorial. Okay, now that we have all that software installed, let's go over the code. In this tutorial, we've created an IBM folder that contains everything you need to connect Python code with the Granite model and a .NET solution. The test.py file is a quick test script. If you execute it and all the libraries are installed correctly, it will load the model and respond to a simple query. The .NET solution is a console application borrowed from an OpenAI example. For function calling, it makes a request, passes a function, and if a tool is needed, the function gets called. The result is sent back to the LLM, which then returns a final response to your query. You can decide whether this process happens on the server or the client, depending on your setup. The chatservice.py file acts as a service that mimics the OpenAI API standard, so your .NET application can communicate seamlessly with it. The models.py file contains the OpenAI object necessary for chat messages, tools, and functions that build the API request and response models. The utils.py file provides helper functions to process requests and responses. To start the chat service, you can run it using the uvcron command or use the VS Code debug feature. We've added plenty of print statements so you can see exactly how the service uses the different objects. If you're using VS Code with an Anaconda environment, activate the environment first. Then open VS Code from the command line by navigating to the directory where your code resides and using the code space period command. When we started this tutorial, only the Granite 3.0 model was available, and it only had a context length of 4K. Now, IBM has released the Granite 3.1 model, and we tested it. The current code works as expected. All you need to do is pass the 3.1 model name. Granite models come with a range of capabilities in several configurations: 8 and 2 billion dense parameters, as well as 1 in 3 billion mixture of experts variants. The new 3.1 model significantly upgrades the context list to 128K. And that's it. I hope this tutorial was helpful. If you enjoyed it, please click like and subscribe. And don't forget to hit the notification bell for more content.